You've been told to shut up and calculate, to stop asking why, to accept that it works, to be satisfied with predictions instead of understanding. That frustration you feel when someone says "for all practical purposes," as if that's supposed to end the conversation. Let me tell you something. You're not wrong to refuse, and today I'm going to show you why that refusal might be the most scientific thing about you. Here's the thing about quantum mechanics that nobody wants to admit. It works perfectly, stunningly well. Every prediction confirmed, every technology based on it, your smartphone, your computer, the laser in your eye surgery, flawless execution. And yet, the better it works, the more uncomfortable the questions become. Because when you ask, "But what does it mean?" When you demand the whole story, not just the recipe for predictions, you get a very specific answer from the physics establishment. Don't ask, just calculate. I want you to really hear this. That need you have to understand the complete picture, to know what's actually happening beneath the mathematics, that's not a weakness. That's not you being difficult or philosophical or unscientific. That's you doing what every great scientist in history has done, refusing to accept a black box when you were promised truth about nature. The frustration you feel when someone dismisses your questions as just philosophy, when they tell you the quantum description is the whole story and there's nothing more to know. That frustration is appropriate, because what you're being offered is a kind of intellectual surrender dressed up as pragmatism. And here's where it gets interesting. What if I told you that your refusal to accept this answer is backed by something called scientific realism, the very foundation that made modern science possible? Ready to go deeper? Let's talk about what you actually want. Not "make me feel better about quantum weirdness." Not "give me a simplified analogy that kind of works." You want the truth about what's really going on. You want to know if there's a real world out there, independent of whether you're looking at it. You want to understand if your cat exists when you're not in the room. These aren't silly questions, they're fundamental. And the establishment response, "That's not a scientific question," is actually a radical departure from the entire history of science. Classical physics gave us a worldview. It told us not just what would happen, but painted a picture of reality itself. Atoms moving according to laws, a clockwork universe we could visualize and understand. Quantum mechanics gives us predictions, perfect predictions. But it refuses to paint the picture. The question is, should we accept that trade-off, or is demanding more actually the scientific stance? Pause with that for a moment. Before we go further, I need to show you something that will make your head spin, but stay with me because this is where the real discomfort begins. There's a principle called complementarity. Sounds innocent enough. Here's what it actually means. A quantum object, an electron, a photon, an atom, has two completely contradictory aspects. Wave nature and particle nature. Both are necessary to describe it fully. But here's the kicker. You can only observe one at a time. Which one appears? That depends on what kind of experiment you choose to perform. Your choice of measurement determines which face of reality shows up. Now you might think, okay, so it's both, and we just see different aspects. But it's deeper than that. Let me walk you through an experiment that will show you exactly how disturbing this gets. Imagine you have 1,000 pairs of boxes. Each pair contains a single atom in a superposition state, meaning it's somehow in both boxes at once until you look. You open one box from each pair. What happens? About half the time you find the atom. Half the time the box is empty. Fair enough. That's quantum mechanics doing its probabilistic thing. Now here's where it gets wild. You throw away all the pairs where you found the atom, because opening that box obviously disturbed the system. You keep the 500 pairs where the box was empty. Those remaining atoms, the ones you didn't find, they haven't been physically disturbed at all, right? The box you opened was empty. The atom is still pristine in the other box. So those atoms should still be in superposition. They should still create an interference pattern if you test for it. But they don't. No interference. The wave function has collapsed, not from physical disturbance. You never touch those atoms. From knowledge. From the mere fact that you now know which box they're in. Think about what that's saying. Information about the system is enough to change the system. Your knowledge collapses reality, not your eyeballs, not your measuring device bumping into things, your knowledge itself. This is complementarity taken to its logical conclusion. The quantum state isn't just unknown until you measure it. It's undefined until the information exists. And here's my question for you. If knowing where something is makes it no longer be in superposition, even when you never touched it, what does that say about the nature of reality before you knew? Was it real? Was it there? Copenhagen says, don't ask, just calculate. The wave function tells you everything there is to know. But does it? Here's the uncomfortable truth that follows from this. If Copenhagen is right, then the properties of quantum objects don't exist independently of observation. They're created by the act of measurement. Your electron doesn't have a position until you measure position. It doesn't have momentum until you measure momentum. The quantum world has no inherent properties, no independent existence. It's observer created all the way down. Now, before you retreat to, well, that's just tiny things, let me stop you there. Because here's what nobody tells you when they're teaching you to shut up and calculate. Big things are just collections of small things. Your desk is made of atoms. Your cat is made of atoms. If we're being consistent, if quantum mechanics is truly fundamental, then this observer dependence should apply all the way up. Which means if you follow the logic, nothing has definite properties until observed, not just electrons, everything. And suddenly we're in very uncomfortable territory. Let me show you where this gets truly disturbing. There's a concept called counterfactual definiteness. Big words for a simple idea. It's the assumption that you could have done differently than what you actually did. Right now, you're watching this video. Counterfactual definiteness says, you could have made a different choice. You could have scrolled past. You could have stopped watching 2 minutes ago. Every legal system on Earth assumes this. We put people in prison because they could have decided not to pull that trigger. Our entire moral framework rests on the idea that alternative possibilities were real, that you're responsible because you could have chosen differently. It's such a basic assumption that we don't even notice it. Of course, you could have done otherwise. You feel it. You're completely confident of your own free will. But here's what Copenhagen Interpretation actually says. Not done experiments have no results. Think about what that means. The experiment you didn't perform, it has no answer. The measurement you could have made but didn't, meaningless to even discuss. Only the actual performed experiment exists. Everything else is speculation. Apply that to your life. The choice you didn't make? According to quantum mechanics, there's no fact of the matter about what would have happened. The alternative timeline you imagine, if only I had done X instead of Y, that's not a real thing that exists in any sense. Counterfactual definiteness might be an illusion we're living inside. And here's the vertigo-inducing part. If it is an illusion, then what does that mean for responsibility, for choice? For the feeling you have right now that you're freely deciding whether to keep watching or click away? You run your entire life assuming counterfactual definiteness. You make decisions weighing alternatives. You feel regret about roads not taken. You hold yourself accountable for choices you could have made differently. But quantum mechanics, taken seriously, taken consistently, seems to say this is all built on a foundation that doesn't exist. Now, the Copenhagen response is predictable. Oh, for all practical purposes, you can assume classical behavior at the macro scale. Don't worry about it. But that's not an answer. That's an evasion. Because if the theory is truly fundamental, if it's really describing the deepest nature of reality, then its implications should be consistent from bottom to top. You can't say quantum mechanics is the fundamental truth and then retreat to, but ignore what it says about free will and choice because that's uncomfortable. Either the theory applies universally or we need to explain exactly where and why it stops applying. And Copenhagen tells you to stop asking. Shut up, calculate, don't think about the implications. Is that really where we want to land? Let me be really honest with you about where this leads. If quantum mechanics is right, and if Copenhagen interpretation is the final word, then here's what follows. Your free will, that absolute certainty you have that you're making choices right now, might be a sophisticated illusion. The feeling is real, but the metaphysical fact, potentially absent. We build our society on the assumption that people could have done otherwise. Our legal systems, our moral judgments, the entire structure of responsibility. We put people in jail because they could have decided not to pull that trigger. But quantum mechanics says, not done experiments have no results. The trigger pull that didn't happen? That's not a real counterfactual. It has no defined answer. Think about that. We incarcerate human beings based on an assumption that quantum theory appears to deny. Now here's where it gets even more disturbing. In Bohr's time, you could draw a line. There was a clean separation between the quantum world and the classical world, a no man's land where somehow the weirdness transformed into normal behavior. You could live with two sets of rules, quantum for the small, classical for the big. Don't ask how they connect, just calculate in each domain. But that line has been eroding for decades. Today, we can see individual atoms with the naked eye using the right laser setup. Scanning tunneling microscopes can pick up and place single atoms. Scientists have literally written the name of their company using 35 argon atoms arranged one by one. Quantum mechanics now applies to bigger and bigger objects. Some physicists even write wave functions for the entire universe. The no man's land has vanished. The boundary between quantum and classical has collapsed, which means we can't hide in that comfortable separation anymore. Can't say weird rules for small things, normal rules for big things without explaining exactly where and why the transition happens. And that explanation? Nobody has it. So the discomfort spreads upward, from electrons to atoms to molecules to, where does it stop? Or does it stop at all? I want to show you something that captures this tension perfectly. It's a dialogue, a dramatization of the conversation between someone demanding answers and the Copenhagen establishment. I call them the objector and the Copenhagenist, and I suspect you're going to recognize yourself in one of these voices. Let's listen in. Objector. This violates common sense. It contradicts everything we know about how reality works. Something must be wrong with the theory. Copenhagen. The theory has never made a wrong prediction. Not one. It works flawlessly, perfectly. What more do you want? Objector. But the better it works, the sillier it looks. You're telling me nothing has properties until I look at it. That's not even internally consistent. How can observation create the properties of the thing being observed? Copenhagen. Einstein tried to prove that for decades. He gave up. You really think you're going to find the inconsistency that escaped Einstein? Objector. So you're saying quantum mechanics claims that small things don't have their own properties, that I literally create what I see by choosing to look. The act of observation brings reality into being. Copenhagen. Yes, you're actually grasping the basic idea quite well. Objector. But that means they have no physical reality. Electrons, photons, atoms, they're only real when being observed. The rest of the time, they're just mathematical possibilities. That's absurd. Copenhagen. Don't worry yourself about reality or making sense. These are just models, useful tools for prediction. Models don't need to make sense to you. They just need to work. Objector. But large objects are just collections of small objects. Atoms. If you want to be consistent, if quantum mechanics is fundamental, then it should say that nothing, not even my cat or my desk, has reality until it's observed. Copenhagen. Well, yes, if you insist on pushing it that far, but it's not important. Objector. Not important? You're telling me my cat doesn't exist until I look at it, and that's not important? Copenhagen. No, everything is fine. You'll never see the craziness with large objects. For all practical purposes, big things are always being observed. By air molecules, by light, by thermal radiation constantly, so they're always collapsed into definite states. Objector. For all practical purposes, sure. But what does it mean that reality is observer-created? What are the implications for how the universe actually works? Copenhagen. Science doesn't provide meanings. That's not our job. Science tells you what will happen in an experiment. Meaning is philosophy. Objector: I want more than a recipe for making predictions. If you're telling me common sense is wrong about reality, then I want to know what's actually right. What's the true nature of things? Copenhagen: We've already agreed quantum mechanics is right. The Schrödinger equation tells you everything that will happen. What more is there? Objector: I want to know what's really going on. I want the whole story, not just the computational algorithm. Copenhagen: The quantum mechanical description is the whole story. There is nothing more to tell. You're asking for something that doesn't exist. Objector: But there's a real world out there, independent of us. I want to know the truth about nature, not just what my instruments will read, but what is. Copenhagen: Science cannot reveal the real world beyond what we observe. Everything else is just philosophy, and frankly, it's a waste of time. Objector: That's defeatist. You're abandoning the entire mission of science, to understand reality, and replacing it with instrumentalism. I will never be satisfied with such a superficial answer. Copenhagen: Too bad, but don't bother me with your philosophy. I have actual scientific work to do. Now, if you'll excuse me. Shut up and calculate. That's the final answer. That's where the conversation ends, and here's my question for you. Which voice is yours? Are you the objector? Refusing to accept that it works is enough, demanding to know what's really happening, insisting that science should provide understanding, not just predictions? Or have you made peace with Copenhagen? Accepted that we can't know the real world, that models are just tools, that asking why is a philosophical indulgence? Because here's what I've noticed. Most physicists are Copenhagen in the lab and objectors at home. They use quantum mechanics all day without thinking about its implications. Then they go home and live as if objects exist independently, as if they have free will, as if counterfactual definiteness is real. It's a kind of intellectual schizophrenia, two worldviews, no bridge between them. And the uncomfortable truth is this: that split is sustainable when the quantum world stays small and distant, when atoms are invisible and electrons are abstract. But when the boundary dissolves, when quantum effects scale up, when we can manipulate individual atoms and write wave functions for bigger and bigger systems, the schizophrenia becomes harder to maintain. The objector's questions become harder to dismiss as just philosophy. And the demand for the whole story, not just the recipe, becomes more urgent. So I'll ask again, which voice is yours? Drop a comment, one word, objector or Copenhagen, because what happens next depends on which side you're on. So that's the situation we're in. The most successful theory in the history of science. Perfect predictions, flawless technology, a mathematical structure of breathtaking elegance. And yet, it refuses to tell us what's actually happening. It offers no worldview, no picture of reality, just a calculation machine that spits out probabilities. Shut up and calculate isn't a joke or an exaggeration. It's the actual operating principle for most physicists most of the time. And for practical work, building quantum computers, developing new materials, creating technologies, it's fine. It's wonderful even. But for anyone who came to physics wanting to understand the universe, for anyone who thought science was about revealing truth, not just predicting instrument readings, it's a bitter pill. Because what you're being asked to accept is a kind of permanent mystery. Not, we don't know yet. That would be fine. Mystery is part of science. Unsolved problems drive progress. No, you're being told, this is unknowable in principle. Stop asking. The question itself is meaningless. And if you push back, if you say, I refuse to accept that, you're dismissed as philosophically naive, as someone who doesn't understand how science really works, as clinging to outdated notions of scientific realism. The implication is clear. Mature physicists accept Copenhagen. Only amateurs and philosophers keep demanding more. It's a very effective rhetorical move. It positions your very reasonable question, what's really happening, as unsophisticated. And for a long time that worked. The authority of the Copenhagen interpretation was unassailable. Einstein objected, sure, but Einstein was old, stuck in classical thinking, unable to accept the new paradigm. Shut up and calculate became the mantra, and most physicists did exactly that. But here's what nobody tells you. That acceptance? It's not based on Copenhagen being right. It's based on Copenhagen being useful, and those are not the same thing, not even close. Here's what they don't tell you when they're teaching you to shut up and calculate. There's a principle called scientific realism, and it's not some fringe philosophical position. It's the foundation that made modern science possible. Scientific realism says this: the objects of scientific knowledge exist and behave independently of our knowledge of them. The planets were orbiting the sun before we discovered heliocentrism. Atoms existed before we detected them. The laws of nature operate whether or not we're watching. This seems obvious, almost trivial, but it's actually a profound stance about the relationship between knowledge and reality. And it's what allowed science to make the incredible progress it did. Because if you believe in scientific realism, then figuring out the laws of nature means discovering something true about reality itself, not just finding useful computational tools. Classical physics was built on scientific realism. Newton's laws weren't just predictive algorithms, they described actual forces acting on actual objects in actual space. And the worldview that emerged from classical physics? It was satisfying, complete. You could visualize it, a universe of particles obeying mathematical laws, deterministic, comprehensible. That worldview had profound cultural impact. It shaped philosophy, theology, art. It gave people a coherent picture of how reality works. Now here's the kicker. Copenhagen Interpretation abandons scientific realism. Not explicitly, not loudly, but functionally, that's what quantum objects have no properties until measured means. If observation creates properties, if knowledge itself changes what exists, then the objects of our knowledge do not exist independently of that knowledge. That's a direct violation of scientific realism. And here's what I want you to understand. Your discomfort with that, your refusal to accept it, that's not you being unscientific. That's you upholding the principle that made science great in the first place. When you demand to know what's really happening, you're not asking a meaningless question. You're asking the central question that motivated every great scientific discovery in history. When you reject for all practical purposes as insufficient, you're not being difficult. You're insisting on the same standard of explanation that Newton, Maxwell, and Einstein all insisted on. Your refusal to shut up and calculate, that's scientific integrity. Let that sink in for a moment. The establishment position, the one that tells you to stop asking, to accept that meanings are just philosophy, to be satisfied with predictions, that position is actually the radical departure. You're not the rebel here. Copenhagen is. You're trying to hold the line on what science is supposed to be about. Understanding reality, not just predicting measurements, and the fact that this has been turned around, that you're made to feel naive for wanting what every scientist used to want. That's one of the great rhetorical sleights of hand in the history of physics. So let me give you some permissions you might not have known you needed. Permission number 1. You are allowed to be dissatisfied with shut up and calculate. That dissatisfaction isn't ignorance. It's not you failing to understand the beauty of quantum mechanics. It's you recognizing that predictive power and explanatory completeness are not the same thing. A theory can work perfectly and still leave fundamental questions unanswered, and demanding answers to those questions, that's called doing science. Permission number 2. Your confusion is appropriate. There's a famous quote, if I can paraphrase, if you're not baffled by quantum mechanics, you don't understand it. The weirdness you feel, the sense that something doesn't add up, that's not a bug. That's your intellect correctly recognizing that we're being offered an incomplete story. When Bohr said we have to accept complementarity, that particles are both waves and particles but never both at once, your brain's rejection of that isn't stupidity. It's pattern recognition seeing a contradiction. Trust that response. Permission number 3. For all practical purposes is not enough, and you're allowed to say so. Yes, quantum mechanics works. Yes, we can build amazing technology with it. Yes, for engineering and applications, the Copenhagen Interpretation is perfectly adequate. But you're not a calculator. You're a conscious being trying to understand your place in the cosmos, and for that purpose, for making sense of existence, pragmatism is insufficient. You need a worldview, not just an algorithm, and wanting that doesn't make you impractical or philosophical in a bad way. It makes you human. Permission number 4. The conversation is not over. Copenhagen would like you to think it is. This is the final answer. The debate is settled. Anyone still questioning is stuck in outdated classical thinking. But here's the reality. Interpretations of quantum mechanics is one of the most active areas in philosophy of physics. Many worlds, pilot wave theory, objective collapse models, cubism, relational quantum mechanics, smart people are still working on this. Still refusing to accept Copenhagen as the last word. Still trying to find an interpretation that both works mathematically and makes conceptual sense. The fact that your professor or your textbook treats Copenhagen as gospel. That's sociology, not physics. The truth is messier, more open, more alive. Permission number 5. Your demand for the whole story is a scientifically valid demand. When you ask, but what's really happening? You're not asking science to become mysticism. You're asking it to do what it's always done. Explain phenomena, not just predict them. Newton didn't just predict where planets would be. He explained why they moved that way. Gravity forces a coherent causal story. That's what explanation looks like. And it's what quantum mechanics under Copenhagen refuses to provide. Your demand for that level of explanation? That's you holding science to its own historical standard. And here's the deepest permission I can give you. Permission number 6, you're allowed to live in the tension. You don't have to resolve this. You don't have to choose between abandoning scientific realism or rejecting quantum mechanics. You can hold both truths simultaneously. Quantum mechanics is our best theory, and it's incomplete in some fundamental way we haven't figured out yet. You can use the theory, appreciate its beauty, marvel at its predictive power, and still insist that something crucial is missing from the story. That's not intellectual weakness, that's intellectual honesty. The people who've made peace with Copenhagen, who've genuinely stopped caring about the interpretational questions, they're not more mature or sophisticated than you. They've just made a different choice about what to care about, and that's fine for them. But it doesn't have to be your choice. You're allowed to refuse. You're allowed to keep asking. You're allowed to demand more, not despite being scientific, but because you are scientific. In the deepest, most original sense of what that word means. So here we are, at the end of this conversation, and I want to be really clear about what I'm saying and what I'm not. I'm not saying Copenhagen interpretation is wrong. It might be exactly right. The universe might actually be that weird, observer-dependent all the way down, no counterfactual definiteness, no independent reality. That's possible. What I am saying is this. Accepting that conclusion shouldn't be easy. It shouldn't be the default. It should be the last resort after we've exhausted every other possibility. And we haven't. There are alternatives. Interpretations that preserve more of scientific realism. Approaches that try to explain what's happening, not just predict measurements. Some of them have problems. Some seem baroque or ad hoc, but they exist. And the fact that they're usually dismissed as just philosophy tells you more about the sociology of physics than about their merit. The real issue is this. Somewhere along the way, physics decided that understanding reality was optional, that predictive power was enough, that instrumentalism, treating theories as mere calculation tools, was intellectually mature, and a generation of physicists was trained to shut up and calculate. But you don't have to accept that bargain. You can stand with the objector. You can insist on the whole story. You can demand that science do more than predict, that it explain, and when someone tells you that's naive, that you don't understand how science works, that you're clinging to outdated realism, you can smile and remind them that scientific realism built everything they're standing on. That Newton, Maxwell, Einstein, they all demanded explanations, not just predictions. That the great revolutions in physics came from people who refused to shut up and calculate, who insisted on understanding. So here's my invitation to you. Don't make peace with Copenhagen if it doesn't sit right with you. Don't force yourself to accept for all practical purposes if your soul demands more. Stay in the question, hold the tension, refuse the easy answer, because somewhere in that refusal, in that unwillingness to settle for pragmatism over truth, that's where the next revolution might begin. That's where someone might finally crack the interpretational problem, might find a way to have quantum mechanics and a coherent worldview. And if that person is you, the world will thank you for not shutting up, for not just calculating, for demanding the uncomfortable truth instead of the comfortable evasion. If this resonated with you, if you're feeling that spark of recognition, that validation of your refusal, subscribe. Because we're not done with this conversation, not even close. This is episode 18 in the Observer Effect series. And what's waiting for you in episode 19? Let me just say this. There's a thought experiment so disturbing, so mind-bending that Stephen Hawking once said, "When I hear about it, I reach for my gun. It involves something that's simultaneously alive and dead, and it's going to show you exactly why the establishment wants you to shut up and calculate, because the alternative is facing something reality itself seems to resist." Drop one word in the comments. Just one. What's your relationship with shut up and calculate, refusal, acceptance, frustration, curiosity? The full playlist and episode 19 are linked in the description below. Don't miss it. Because this refusal to settle, it starts with you. And what comes next will show you exactly how deep this rabbit hole goes. I'll see you in 19.